Okay, so just now we have started this slide, so 5 minutes have passed. Let's resume our class. All right, so now we will go through the another topics. So it will be on the under frequency protections. All right, so now how does this disturbance occurs for the under frequency situations? It happens is because of this. If you refer to the first bullet point, is that is because we have unintentional splittings of the interconnected generators we have in the power plants. So right now, the generator that is not working will become the isolated area of the system, and this can become the deficiency in terms of power generation, and hence the frequency will start to drop. So let's check out these figures to have a better understanding how does under frequency situations happens. So again, under normal conditions, we will have three generators at the power plant here to feed these two loads. Okay. Now let's say instead of three, I have one of the generators become out, is no longer working due to any reasons. All right, so we have loss in terms of generations. So this time, instead of three, I have only two generators. So under these situations, the speed of the generator will start to drop. So that's how the frequency at the power plant drop as well. So the frequency will drop, leading to under frequency situations. So at the same time, if we have this issue, instead of three, we have two generators. Now, the supplying steam from the speed governors right now might become too much. So it will be condensed on the turbine blades right now. So these high volumes of steam might be causing to the damage to the turbine blades as well. So this is actually the issue we have right now. So now we have lower power generation. So if we have this issue happens at the main power plant, we will actually activate the standby power plant. The standby power plant, also known as auxiliary stations. All right. So these standby power plants, right, might become old as well. All right. So if we have these situations continue to occur, so how we can actually solve this problem? So one of the way is by perform the automatic load shedding, whereby this is a process we are trying to remove the non-important loads until the power generations become enough. Then only we will connect back this load to the system. This is one of the way. It's like a load scheduling. Other than this, we can also use the under frequency relay as well. All right, so to detect if there's a drop of frequency. So one is notice that the frequency is dropped, it will start to trigger alarm to alert the operators who have these situations occurs. So this is for the under frequency protections, and it will be occur at the status site. Okay, so now we will start to talk about the rotor faults right now. So as we know, right, for the rotor, it's the rotating parts of the machines, and this rotor will wound by the winding. All right, so the winding here, the intention is used to drag the magnetic fields. That's why this winding is not as fields winding. This magnetic fields will drag whenever this rotor winding is being supplied with the DC source right now. That's how the magnetic flux is being set up. All right. So once this magnetic flux has been rotated by the prime mover, so if we give the motion to these generators, these magnetic fields will be cut by the status winding. So based on Faraday's law, we have the rotating rotating fields, and then we have flux, and we actually iterate. So voltage as well as a current will start to induce. Okay, so this is how does the generators work. So this is supply from the exciters, right? The one that we supply currents to the rotor winding. This excited might not need to be grounded, all right, dealing with earth fault situations. So what happens if we have this machine here, the generators, to have one earth fault situations occurs at the field winding. Let's say this is a field winding. If let's say here we have 1 point short circuit to ground, we can have this generator continue to be run, right? Why? Because there will be no fault current flowing through the systems right now. This is okay, and only okay if only we have one single fault situations. So what happens if we have second fault situations start to occur at this fuse winding, right? Due to the stress on the insulations now, we have second point short circuit to grounds right now. So the dangers start to arise due to the second fault situations. Why? This is because at this point here, so this entire fuse winding is actually wound around a core, right? This core is actually conductive. All right, so if you have 2 points short to the ground, which means that these sections of the fuse winding will be short to each others. All right, as you can see here, this point, because the winding wound around a conductive core, so these 2 points will form a short circuit condition. So it will actually cut up from the fuse winding. So this part of the fuse winding is being cut, and hence it will cause the fuse current start to increase. All right. As we know, whenever we have higher numbers of turns or higher longer winding, resistance will increase. But right now it's being cut up. So we will have higher fuse currents right now. So higher current flowing through the fuse winding, it will cause the burning on the fuse conductors or fuse winding conductor, I should say. So not only this, whenever we have current flowing through the fuse winding, we know that the flux will also generate, right? So right now the flux generate will become distorted. So causing we have unbalanced magnetic fields. This unbalanced magnetic fields will result the unbalanced mechanical force generated on the rotor. So it will have violent vibrations. And this violent vibration can cause the damage to the mechanical components, including the membrane, and even displace the rotor by amount which foul the status. Alright, so this is the consequences if we have the second or more earth force situations occurs on the fuse winding. Alright, so now let's see the flux distributions for rotor if we have a part of the fuse winding become short circuit. So if you check out these diagrams, right? So the horizontal line is actually the fuse winding, all right? And these 2 points, so we have one short circuit to ground, another point is short circuit to ground. So these sections of the fuse winding has been cut up due to these two fault point right now. So the direct magnetic flux by the rotor is no longer sinusoidal, all right, distribute around the peripherals. Instead, it will adopt such patterns, right, which imbalance, right, due to the imbalance current flow. Okay, so now let's further analyze the flux patterns. All right, so now the flux generates will concentrate on one pole, but while it disperses over the others intervening the surface, it will adopt such patterns right now. So there will be attractive force assist between the pole as well as the status core here, and it become not equal, all right? So it will result the unbalanced force right now. So this unbalanced force on the axis for a large machine, it can be reached in the multiples orders of 50 to 100 times. So which means that the force is very high, which is sufficient to cause the violent vibrations that result in damage the bearing surface, right, causing the rotor displacement. Okay, so now what we can do to deal with this. The solutions you can find in the next slide here. So we have two ways to detect that such kinds of problems. So one is known as potentiometers method. Potentiometer, which means you add a resistance across it. All right, so and this method is only suitable for those generators that has been incorporated with brush in the main generator's fuse winding. So it must have these components here to be used these methods right now. So let's check out this diagram, how actually we can implement this method. So now you can see this is the excitance. This is winding. You will notice that we will have a resistor connect across, all right, in parallel connections to this fuse winding as well as exciters. And then it has been centrally tapped. And this path will be connect with the voltage relay to the ground. So what happens if I have fault situations occurs for the fuse winding? So this voltage right here on the fuse winding, it will actually close this voltage relays through the ground path right now, seeing as we have voltage appears here, so it will appear here as well due to the potentiometers actions of the resistor. So that's how it works to trip this generators. All right, so how about for the another methods here? So it's known as AC injections method. So right now, this method you will notice as a green sector. This is the field winding at the ground path. We'll connect a voltage relay. In between, we will have the capacitors, and the next one here is known as auxiliary transformer. Okay, so this is how we do the connections. But this AC injections methods, right, only applicable to apply for those generators that consist of slip ring connections to the field circuit. So what happens if I have a fault situations occurs for the field swelling? Again, it will close this voltage relay circuits here where the ground path. Why? Because here this is primary, this is secondary. We will have secondary voltage induced or appear across this auxiliary transformer. So it can be measured and causing this voltage relay to trip in the event if I have second or fault conditions. So that's how we deals with this. All right. So now let's move to the next problem that can be occur as the rotor fault for the generators is known as loss of excitations. Okay. This is because we have the rotor field system failures. Okay. So how actually it occurs? So it's due to these four reasons here. First is loss of fields due to main excited. So it doesn't have the magnetic fields being dragged. That's why we have failures for the generators. Next, we might accidentally trip this breakers right now. That's why it's no longer working. Thirdly, we might have fields winding here having short circuit conditions due to the insulation failures. And last one here is because we have no supply to the excited systems. Under these situations, it will cause the rotor field system start to be filled. All right. So under these situations, now we have generator. Yes, it's continue to be booked, but it will be operate as an induction generators. All right. So continue to supply the power demands that determined by the turbine governors. Okay, so to further explain this, let's look into the next slide here by referring to these diagrams. So in the event if I have failures of field excitation, which means that here is no longer working, the DC field source is not working. Okay, so there will no reactive power being supplied to the generators and then to the grid. So instead, you notice that now the generator will try to draw the reactive power from the power grid. So we have reverse directions. All right, so usually we will have positive reactive power. Now we have negative value instead. All right, so with the fact that the excitations fields here, right, we actually produce the force which is opposing to the prime or opposing to the rotor. So because it's not working, it doesn't produce the opposing force. Hence, the rotor of the generator can be rotated much more faster, all right, faster than the synchronous speed of the generator at sleep frequency. Sleep here is a difference between the synchronous speed and the rotor speed. So synchronous speed is the speeds of the rotating magnetic fields being dragged. All right. So now, with such a case, we know that the generator is rotate much more faster. All right, faster at this running as synchronous beat actions. All right. So right now, whenever we have high speed, it will actually cause overheating conditions for the machine, seeing as the machine is not being designed to run such fast manner. So in the long run, the rotor can damage. So what we can do to solve these problems here in the event we have loss in terms of excitations fields. So we can actually make use of mu types impedance relay, right? The most commonly used of impedance relay. So with such a case, if we have these problems, so it will cause the measured impedance values right now become much smaller, right? With the same grid voltage being applied. So that's how we treat these situations. All right, so that is for loss of excitation and is considered as the rotor fault as well. So now let's start to talk about the abnormal operating condition for the generators, which is reverse power flows. So it's a kind of mechanical failures, I can say. So in the event, if there is a failures on the prime mover, which means that there's no motions being given to the generators. So this time, the generators will turn into motor. So it will behave as a motor. So now, instead of supplying active power, it's actually drawing power from the grid instead. Why? Because it want to compensate the loss between the mechanical side and the electrical side. So now we have reverse power flow. So no issue for the reactive power. Why? Because DC field excitation circuit is still working. So we still have positive reactive power. But for active power is reverse as comparing to this. Instead of supplying to grid, we actually draw from grid. So we have negative active pulse right now. So under this situation, of course, is very bad. So this one should give us electricity, but right now it's turned into the load, right? And at the same time, it's running at the speed of the generator. So rotating at the same directions with the rotor system. So these situations will actually aggravate the failures of the mechanical drive, which is the shaft right now. So how actually we can detect these situations? That is by using the power reverse relay. So in the event the power directions swap, we can directly know that this is no longer good as the generators. We might have for problems from the prime mover. Okay, so that's how we deals with this. All right, so now let's look into the last abnormal operating condition for the generators, which is loss in terms of synchronism. So whenever you see loss of synchronism, which means that the generator has been run out of stack right now. So how actually is occur? So for a generators, it can lose its synchronisms with the power system because we have several fault disturbance from the power network. So we have rapidly change of voltage or impedance value due to short circuit conditions or loss in terms of line. So the impedance rise, all right, that will causing the generators become lost in terms of sync. It will no longer operate at 50 hertz. Meanwhile, it can be also happens as well if, let's say, the generator is actually operating under high loads with leading power factors, which is with capacitive loads. So now this disturbance is usually happens on extra high voltage systems. So with such a case, it will cause the rotor start to oscillate. All right, so with huge variations of voltage, currents, as well as power factor. So we have rapid change of these values right now. That's how it's lost its synchronism. Besides this, right, it will also develop a high level of transition shaft torque. So whenever we have high torque, which means that we could have the of the rotor exceed its stable limit. So it will start to slip a pole pitch. Slip a pole pitch, which means it become out of step. So right now the shaft might be break whenever we have pole slip frequency approaching to natural shaft resonance frequency. So it's vibrate at the same frequency. That's why it has become broken. All right, so what is the solution to this to solve the loss of synchronism? All right, so now there's two ways. So the first way is we have to wait this severe disturbance to go away from the power system. So once the disturbance has been passed, and before the generators become out of sync, right? All right, so now we will try to regain its synchronisms. All right, if let's say we're unable to regain the synchronism, we will need to isolate these generators from the system. So this is one way. Okay, the other way you need to trip the field circuit, which means that it will stop the field excitation circuit, so no fields being supplied. Have this machine run as the asynchronous generators. So now, after reducing the excitations fields as well as the load, then only we will turn on back this field switch right now to resync the generator. So this is the another way. Okay, so that's how we solve this problem. So with such, we are reaching the ends of these chapters here. All right, so now before I end the class, do you have any problems? I see no response, so probably have no issue. I hope Adin is here. So for Adin's right, so since you are a Malay student, so for information this time around, right, our final exam will actually having evening slot. So which means that it might actually how to say clash with your prayer times. So with such a case, right, you might need to register with DECA indicate that you are Malay students. So probably you will need extra time for you for the prayer, then we can extend the time for your examination. But this is only can be done if you have registered with DECA. So I see he has no response. So if other students have met him, right? So please tell him to register with DECA, indicate that if let's say the final exam for any course, right, is fall under evening time that crash with his prayer time, so he might need time for the pray, so he will need extra time for exam, so he need to apply with that card. So if there's no question being asked, I will end the class after I count three. All right, three, two, one. All right. So thanks for your attention. I will see you all in this Wednesday.